Yes, good evening. We shall begin with today's part, that is analysis of alloy, that is stainless steel. Stainless steel contains iron and chromium. We have to determine the content of iron and chromium in stainless steel. Normally, one razor blade, which is made up of stainless steel, contains iron and chromium. The exact weight of any razor blade is around 600 milligrams. I'm saying milligrams. So during analysis, we have to take only half part of this blade, which weighs about 0.280 to 0.300. As per the procedure, if we look the procedure, then they have said that the weight of sample should be in between approximately 0.300. That means 300 milligram we have to take for estimation. So based on this, we shall proceed further. So take a look at this usual procedure. The procedure is very simple to understand. Just you have to listen very carefully. So we are performing the analysis of stainless steel. Now, first of all, we have to weigh around 0.300 gram of the sample. Stainless steel, that is razor blade which contains iron and chromium. You should know this because examiner may ask what is the basic radicals which are present in the stainless steel. Your answer should be iron and chromium. Now, to estimate this iron and chromium, first of all, we have to weigh the sample. That means half part of the razor blade that we have to take. And to this razor blade is to be taken in a conical flask. To this razor blade, we have to add 5 ml of concentrated HCl solution, then 1 test tube of distilled water, and we have to place a stem cut funnel. We know the funnel that we are using in laboratory, it is known as a stem cut funnel, and we have to heat this content on low flame. It is seen that in contact with concentrated HCl, this stainless steel material starts to dissolve, and we get a light green color clear solution in a conical flask. When the blade that dissolves completely in this solution, it is known as dissolution of the sample. What is the dissolution of sample? By adding HCl and by heating on low flame, the blade material that starts to dissolve. After complete dissolution, the solution appears to be light green in color. Now, after complete dissolution, we have to cool this green color solution, and we have to dilute this content to 100 ml by using distilled water. Now, this procedure we know: 5 ml HCl, 1 test tube water, and we have to heat on a low flame. First of all, we have to estimate the iron content from this razor blade, that by using gravimetric estimation of iron. So first of all, we have to estimate iron gravimetrically. For this, first of all, we have to take 25 ml of this diluted solution of sample by using a burette. This solution is to be taken in a beaker, 250 ml beaker preferably. Then to this beaker, we have to add 5 ml of dilute sulfuric acid, that is a table reagent, and about 2 ml concentrated nitric acid, that is HNO3. Here, by adding this HNO3, that is a nitric acid, we have to boil this solution. We have to boil this solution till the solution turns to be yellow in color. That means here light green color solution that is obtained. That means here iron is in plus oxidation state. We have to oxidize the iron into plus 3 oxidation state, and we know ferrous salts are light green in color. For example, ferrous sulfate crystals we have seen in the laboratory, while ferric chloride solution, that is brownish yellow in color. So when the solution turns yellow in color, this is a perfect indication that the almost all ferrous ion is oxidized into ferric state. So nitric acid acts as an oxidizing agent. So 25 ml diluted solution, 5 ml H2SO4 and 2 ml concentrated HNO3. After boiling for about 2 to 4 minutes, the solution turns to be yellow in color. Now, after the yellow color that is obtained for solution, we have to stop the heating of the solution. At this stage, we have to add around 500 gram, that means 500 milligram of solid ammonium chloride, which is white color crystals, and then we have to add 1:1 ammonia solution dropwise. Here, when we add 1:1 ammonia solution, then a reddish brown colored precipitate of ferric hydroxide is obtained. You have seen while studying your gravimetric estimation of iron at your TY level last year, the reddish brown colored ferric hydroxide precipitate that is found, we have to add this ammonia till smell of ammonia. That means when we have a smell of ammonia on the beaker, this indicates that complete precipitation has took place of iron. So the precipitate thus obtained is of ferric hydroxide. Now, after complete addition of this 1:1 ammonia solution to this beaker, now we have to filter the solution through ordinary filter paper. Then, after filtration, as we know, a precipitate that is formed, which is retained by the filter paper, and filtrate that is collected at the bottom. Now, we have to reject this filtrate, or we have to discard this filtrate, and we have to use this precipitate for the gravimetric estimation of iron. Now, just a minute. Now, we have to use this precipitate. Now, after discarding this filtrate, we have to use this precipitate. Now, suppose for example, this is our filter paper, and here the precipitate that is obtained, this precipitate is of ferric hydroxide, as we know. Now, the whatever filtrate that is there, that filtrate should be rejected. Now, after a rejection of the filtrate, we have to pierce this filter paper. Pierce means we have to make a small hole at the bottom. That means here we have to torn this filter paper. Because the filter paper is moist, we can very easily torn this filter paper at the bottom. And now to this precipitate, we have to add again 10 ml to normal NaOH solution. Again, after adding this NaOH solution, this is to be collected in a separate beaker. Here, we have to keep a beaker to receive whatever the content that is obtained here by adding NaOH solution. Then, after adding NaOH, we have to add again 10 ml of 3% solution of hydrogen peroxide. We have to add, first of all, we have to add NaOH solution, then we have to add hydrogen peroxide solution, 10 ml of 3% solution. that is to be added in a circular fashion so as to collect all the precipitate in a beaker. So this particular washing of ammonia and hydrogen peroxide ensures that almost all the precipitate that is collected in the beaker. Now, again to this beaker, 10 ml NaOH is to be added. So NaOH is to be added 2 times. First of all, to washing the precipitate. After collection of this precipitate, again we have to add NaOH, and now we have to boil this beaker by keeping the beaker on a tripod stand. Now, when we boil this beaker here, the precipitate of ferric hydroxide, remains undissolved. That means no effect takes place substantially by adding this NaOH solution. So we have obtained here undissolved condition of ferric hydroxide in this case, which contains also chromium in addition to iron. Now we have to separate a chromium from iron. For this purpose, we have to filter this solution. After filtration, again we have obtained a precipitate and a filtrate. The precipitate which remains here undissolved, which is collected on a filter paper, this is precipitate is of ferric hydroxide, and filtrate which is yellow in color, it is definitely of chromium. So this is how we have separated iron from chromium. Now the things are very simple. We have to estimate iron first, followed by chromium. Now to estimate this iron, first of all, whatever filtrate and precipitate, say for example, this is our filter paper, over which here the undissolved ferric hydroxide that remains, and in the form of filtrate, which is yellow in color, chromium is obtained. So here iron is retained by filter paper while the filtrate contains chromium. Now this is how we have separated this. Now we have to wash this precipitate by using, here we have to wash the precipitate by using hot distilled water around 1 test tube, and we have to collect the filtrate and washings in a separate beaker. Now here we are with ferric hydroxide precipitate. Now what we can do, we have to dry this precipitate in an electric oven. Then we have to ignite this precipitate in a crucible. You might have seen this crucible. It is very small porcelain like material, and you can see this. This crucible is to be heated previously and it is cooled, and after cooling we have to take the bed of empty crucible. Now we are with this dried precipitate. This dried precipitate along with Hartmann filter paper number 41, we have to keep that paper along with the precipitate in this crucible, and this crucible is to be heated electrically at around 700 to 800 degrees centigrade. When complete burning of paper takes place, we have obtained somewhat brownish colored crystals, which are nothing but these are ferric oxide is obtained. So we have converted ferric hydroxide into ferric oxide by the removal of moisture content, and by taking the weight of this residue, what we call this as a X, we can calculate the quantity of iron. So this is how we can calculate the quantity of iron in this fashion. So this X, that is the weight of this ferric oxide, that ensures the weight of iron that is present in stainless steel blade. Now our job is to treat this filtrate for the determination of chromium content. So to determine this chromium content, what we follow? Now we are with the washings and the filtrate, which is yellow in color. The yellow color is due to presence of the chromium as a basic radical which is present in stainless steel. How can we estimate this chromium? Again, we have to estimate this chromium by gravimetric estimation. So, for the estimation of chromium by gravimetrically, what we have to do, the yellow filtrate we have to treat. To this yellow filtrate, we have to add 10 ml of acetate buffer, which is a already prepared solution. You are not expected to prepare, it is already prepared. We have to add just 10 ml of this acetate buffer solution to the yellow filtrate. Then we have to add around 40 ml 4% solution of lead nitrate, PbNO3 twice. So by adding 40 ml 4% lead nitrate solution to this yellow solution, so the yellow solution contains lead chromium, and this lead nitrate contains lead radical. So here we have obtained PbCrO4, that is known as lead chromate, which is almost canary yellow in color, very fine yellow color that is obtained. So the lead radical from lead nitrate combines with chromium from this yellow filtrate and it forms lead chromate. Now, this is how we have separated or precipitated the chromium from this. Now we have to digest this precipitate of lead chromate for around 30 minutes. So after digestion, what is the digestion procedure? We have to heat the precipitate along with the mother liquor for about 30 minutes on a sand bath or on a water bath. After 30 minutes, the supernal liquid on the beaker that becomes clear, and at the bottom we will obtain the crystals of lead chromate. At this stage, we have to take a Gooch crucible. This is a specially designed crucible. If you are very much interested, then you can search on the Google. It is somewhat like this. Here, this is a glass material, forming glass, and here a filtering medium is there. Filtering medium is there, and here this is known as a Gooch crucible. First of all, we have to clean this Gooch crucible and we have to take the weight of empty crucible. Here, this filtering medium, that means when we add the digested solution in this Gooch crucible, then this filtering medium that preferentially retains the precipitate of lead chromate, PbCrO4, and here we have obtained the filtrate or the mother liquor. And here this Gooch crucible is to be mounted on a specially designed, this is known as an adapter, over which this Gooch crucible is to be kept, and by using suction pump, the solution can be filtered, and it can be easily filtered by using this suction pump. And we have to wash this precipitate with hot distilled water also. After complete transfer of this lead chromate precipitate, which is obtained in the yellow form, here the crystals are obtained, very fine yellow colored crystals are obtained. Now this crucible is to be kept in an electrical oven, and the temperature should be maintained in between 100 to 120 degrees centigrade, because if we increase the temperature beyond this limit, then this filtering medium may get melt. So we have care should be taken that the temperature should be 100 to 120 degrees centigrade. After around 20 minutes, this precipitate is free from moisture and the precipitate is now dry, and a yellow colored cake is obtained. This is nothing but it is of lead chromate. We have to weigh this Gooch crucible. We have to weigh this Gooch crucible along with the precipitate, because we have weighed this crucible before the transfer of the precipitate, and after transferring and after drying of this precipitate, we have to take the weight. So the weight of this gauge crucible is higher than the previous, that is empty. So if we subtract the weight of empty crucible from this weight, then we have obtained the weight of the precipitate of lead chromate, which we call as a capital Y. So in previous case, X gives us the value of iron content, and in this case, the value of Y gives the value of chromium. So by using relation that I will send you on the group, so by using this relation, one can calculate the content of iron and chromium in stainless steel material. So this is how we can estimate the chromium from stainless steel. Now we have to estimate the over analysis, which is also very simple. If you listen it very carefully, then it is very easy. Now see here, over. First of all, we shall see the determination of dolomite. Examiner may ask during exam time, what is the ore? Ore is nothing but it is a naturally occurring substance which contains metal in free state or metal in combined state is known as a ore. So it is a naturally occurring substance which contains metal either in free state or in the combined state. And as we know that almost all the metals are very reactive, so they do not found in nature in free state. They are always associated with the atmospheric oxygen or atmospheric silica or atmospheric carbon dioxide and so on. So the metals are always associated with some non-metallic stuff. Dolomite ore is nothing but it contains calcium and magnesium in the form of carbonate. That means calcium carbonate and magnesium carbonate. Our aim is to determine the content of calcium and magnesium in the dolomite ore. So the usual procedure that we have to follow. First of all, we have to take or we have to weigh the sample of ore, which is around 500 gram. Then to this sample, this is to be taken in a conical flask, and to this sample, we have to add 15 ml of concentrated HCl followed by 5 ml of concentrated HNO3, and we have to boil this solution by keeping again a stain cut funnel. After boiling for about 5 to 10 minutes, we have to filter this content. So after filtration, a precipitate is obtained and a filtrate is obtained. Here just now in the beginning I have told you that calcium and magnesium content is to be calculated, but as the ore is naturally occurring, it may contain silica also. So we have to determine the silica content also. So the precipitate contains silica, that is in the form of SiO2. So this filter paper that we have to dry, and this filtrate is to be collected for the estimation of calcium and magnesium, and silica content here can be calculated. So after filtration, we have to wash with hot distilled water, and we have to collect the filtrate and washings in a separate receiver. So by following the usual procedure, we can dry this filter paper, and we have to weigh by igniting this in the previously weighed crucible. So this is how we can determine the content of silica. Now our aim is to determine the calcium and magnesium content. Now to determine the calcium and magnesium content from dolomite ore, first of all, we have to dilute the filtrate and washings to about 250 ml by using distilled water. So the filtrate and washing thus collected, those are to be diluted to 250 ml by using distilled water. And from this solution, we have to take 100 ml diluted solution for our estimation of calcium and magnesium. Now, to this 100 ml solution, first of all, this solution, 100 ml solution, that we have to boil carefully. Then we have to add 10 ml again acetate buffer solution, which is already prepared. Ready-made solution is there. Just we have to add 10 ml solution to this 100 ml solution after boiling. Then to this solution, boiling solution, we have to add 25 ml of 5% ammonium oxalate solution, which is a 5% means 5 gram of ammonium oxalate solid is to be taken and it is dissolved in 100 ml. So 5 gram ammonium oxalate dissolved in 100 ml distilled water that prepared, that is a 5% solution. So 25 ml of 5% ammonium oxalate solution is to be added into this solution. Now, after adding this, we have to digest by keeping the beaker on a hot water bath for about 30 minutes. After 30 minutes or so, the supine liquid becomes clear and at the bottom of the beaker, we can see a white colored precipitate that settles down. After this, we have to filter the content by using Whatman filter paper number 41. So after filtration, we have again two parts of precipitate and a filtrate. By adding this 5% solution of ammonium oxalate to this solution, whatever calcium is there, that is converted into calcium oxalate. So ammonium oxalate, the ammonium ion is replaced by calcium, which turns to be calcium oxalate, which is a white colored precipitate. So this is how we have separated calcium, and the filtrate contains magnesium. Now we have to treat this calcium, that is a precipitate. So the calcium oxalate precipitate, first of all, say for example, this is our filter paper. Here the calcium oxalate solution precipitate is there. Again we have to pierce this filter paper. That means we have to turn this filter paper, and to this precipitate we have to add 2 normal sulfuric acid around 1 test tube, because 1 test tube sulfuric acid is sufficient to dissolve this calcium oxalate solution, and this is to be collected. All this content is to be collected in a 250 ml volumetric flask, and these contents are to be diluted with this water to 250 ml. After dilution, we have to pipette out 25 ml of this diluted solution of calcium oxalate. So here, after adding sulfuric acid, calcium oxalate will be converted into calcium sulfate because of sulfuric acid. So calcium oxalate is converted into calcium sulfate by adding sulfuric acid. So it gets dissolved. Now, to this, from this 25 ml of the solution that is pipetted out, we have to add 1 test tube of 2 normal table reagent, that is sulfuric acid. This solution is to be heated approximately to 60 to 70 degrees centigrade temperature, and all these contents are to be titrated against 0.025 normal solution of potassium permanganate. Here, the end point is colorless to faint pink color. So here, by using this constant butyrating for this calcium sulfate solution, we can calculate the percentage of calcium in the dolomite ore. So this procedure that we have followed at our BSc part 3 level, that is determination of oxalato group from the given solution of potassium trialuminate 3. So oxalato group from this that reacts with this KMnO4. This is an example of the redox titration. Here the solution that we have taken 25 ml solution in a conical flask that acts as a reducing agent, and KMnO4 which is taken in a burette that acts as a oxidizing agent. So it is an example of redox titration. So by knowing the constant burette reading, we can calculate the quantity or the percentage of calcium in the dolomite ore. Now we are left with this filtrate which contains this magnesium. So how can we determine the magnesium content? Just see here. To treat this, we are with the filtrate which contains magnesium. How to calculate this magnesium? See here. This filtrate is first of all diluted to about 250 ml by using distilled water. Now after dilution, we have to pipette out. We have to pipette out 25 ml of this diluted solution in a conical flask. 25 ml of solution in a conical flask. To this solution, 10 ml of ammonical buffer solution is to be added, which is a ammonium chloride and liquor ammonia solution, which is known as a buffer solution having pH 10. After adding buffer solution, we have to add iriochrome black tea indicator, which initially turns the solution color of the solution to wine red. We have to titrate the solution by using 0.01 molar ethylene diamine tetraacetic acid solution, that is EDTA solution, until at the end sky blue color is obtained. So wine red to sky blue is the end point of the titration. So by knowing the constant burette reading, we can determine or we can calculate the quantity of magnesium that is present in the dolomite ore. So this is how we can calculate the quantity of calcium, magnesium volumetrically and the quantity of silica gravimetrically. So by following this procedure, we can calculate the percentage of calcium, magnesium, in addition to which we can also calculate the quantity of the silica also. So these calculations that I will again send you on your group. So only 2 to 3 minutes are left. I have to discuss only one experiment, that is one more ore is that is a chalcopyrite. So you have to click the same link and again you have to rejoin. So I will complete this practical part today. So you have to rejoin once again.